Dear students, in this video, I will answer you question number 8 from Pearson Edexcel A-Level exam for Mechanics 1. This exam is taken in May-June session year 2023. Paper reference code is WME01/01. A square floor space ABCD with center O is modeled as a flat horizontal surface measuring 50 meter by 50 meter as shown figure 5. The horizontal unit vectors I and J are in direction of AB and AD respectively. All position vectors are given relative to O. A small robot R is programmed to travel across the floor at a constant velocity. At time t equals to 0, R is at the point with position vector -2i plus j meter. At time t equals to 11 seconds, R is at point with position vector 9i plus 23j meters. At time t seconds, the position vector of R is r meters. Find in terms of t, I and j an expression for R. Actually, we need to find the vector equation for this R. We know the basic formula for writing the vector equation is R equals to R naught plus Vt. These are vectors. Okay, this is the basic formula of finding the position vector of any point after time t, where R naught is the starting point. Here, when t is 0, we could say this is R naught. This is also a position vector after 11 seconds. So this is R. It is after time t 11 seconds. So this is the position vector R. And velocity is not given here. If you read all the statement, there is no velocity given. So we could find this velocity by using this formula. Let me write the values given here for the first part. For the first part, we know that the starting point is R naught. That is equals to, we can write in vector form, that is -2i plus j. So we can write as -2 and 1. And after 11 seconds, what is the position vector? That is 9i plus 23j. So it will be 9 and 23. Time taken is 11 seconds. We know the formula. This is the position vector for R after 11 seconds. What is the formula? That is, this is the standard formula of representing the position vector after some certain time t. This is the standard formula you have to memorize. R and R naught. R naught is the starting point, starting vector when t is 0. This is after some time t. Now plug in the values to get the value of V from here. R is 9 and 23 equals R naught -2 and 1 plus V we need to find, and t is 11. You can write over here. We'll move this value there. So we can write as 11V is equals to 923 minus -2 and plus 1 here. Corresponding numbers will be added together like this. Minus and minus makes it plus. So it becomes 11. And this will be 23 minus 1 will be 22. And also you can bring this 11 there. We can write as 1 over 11 equals to V. V is a vector. Now this 11 will divide both numbers. We get the vector, the velocity V, the constant velocity with which it is moving. So 11 will divide with both numbers. So its answer will be 1 and 2. Now plug this value into the standard formula of the vector equation. That is R equals to R naught plus Vt. Here R naught is given there. That is -2 and 1 plus V. We just got it. That is 1 and 2, and T keep as is. This is after some time, like after 1 second, 2 seconds, 11 seconds, whatever the time is. You could find the position of that robot R. So you can combine them together. So we can write as -2. This T will multiply there. So you can write as -2 plus T, and 1 plus this 2T will multiply there. You can write as 1 plus 2T. Because this is the demand of our question, we should write our answer in this form, I and J. So you can reconvert this one into the standard form of the vector equation. Like this is the coefficient of I. So it will be -2 plus T, -2 plus T I, plus this is the coefficient of J, 1 plus 2T into J. So this is the vector equation for robot R after time t. First part is done. Now for the next part, a second robot S is at point C. At time t equals to 0, S leaves C and moves with constant velocity. Here velocity is given there. At time t seconds, the position vector of S is S meters. Write down in terms of t, I and j expression for S. It means you need to find the vector equation of this one, point S. Okay. At time t, the position vector of S is the robot. You need to find the position vector of robot S after time t. Like here in the previous part, we found the position vector of R, the robot R, after time t. Now you need to find the position vector of robot S after time t. It is similar question, but here velocity is given, but starting point is not given. Starting point, how could you find here? Look here. At time t equals to 0, robot S leaves C. Go back to the figure. Robot at time t equals to 0, robot S was here at point C. At t equals to 0, robot was here. So if you notice that O is the midpoint, you can go this way. And here, at this point, when time t is 0, you know the position vector is always measured from the origin to that point. This position vector is R0 actually. Got it? This position vector of robot after time t is R0. You know that total is 50, so this way it will be 25. So this vector is 25i. And here also it is the halfway, so this will be 25j. You know the vertical axis we are taking j and horizontal we are taking I. So R0, the starting point we could get from here, 25i plus 25j. Instead of writing R0, we can write here S0 because the robot is S this time. So better you write over here S0. The robot is S. So because we already know, actually this is the basic formula. You can write here S0. Got it? S0 because S0 will be the position vector for robot S. For second part, the starting point, starting vector will be 25i plus 25j. So it will be 25 and 25 here. Got it? And velocity is given there. In second part, the velocity of S0 is -1 and -1. Here, this one is the velocity, constant velocity for S. -1 and -1. -1 and -1. Okay. Now we can make the position vector for S. Robot S will be S0 plus Vt. Same method like we did there. The standard formula R equals to R0 plus Vt. Here only the difference, we are using S to represent the vector for robot S. So this is the position vector of robot S after time t. Plug in the value. S0 is 25 and 25 plus this is -1 and -1. T key passes. So you can combine them together. So it will be 25 minus t and this one will be 25 minus t. Therefore, the position vector of S will be after time t will be 25 minus t I plus 25 minus t j. So this is the answer for the second part. Second part is done. Let's move on to the second last part of this question. Show that SR equals to 2t minus 27i plus 3t minus 24j meters. It means you need to find the position, you need to find the vector SR. There is a trick I will tell you now. Easiest way, like if you want to find any vector, what we do, we subtract the tail from head. So we can write as SR equals to OR head minus tail. It is the easiest way of getting the vector. Like if you want to find vector AB, we will write as head minus tail. It will be OB minus OA. Got it? It is the easiest way of finding any vector. Why it is like that? For example, this is the position vector for S. Let's say this one. And this is OS. This is OR. And if you want to find SR, look at this diagram. We can say OR is equals to, look here, OR is equals to, you can go to the alternative path. It will be like this, OS plus SR. OS plus SR. From here, if you want to get the value of SR, this will go there. I think this is more easier way, like head minus tail. So keep this one. Actually, this vector R is the position vector of the robot R. We can say it is OR. And here, what we got here, this one is OS. So we have these two position vectors, OR and OS. So straight away, we can get the value of SR. For this part, see, SR is equals to OR minus OS, head minus tail. Plug in the values. So we can use this value instead of this one in column vector form. It is more easier to solve. Minus 2 plus t, minus 2 plus t, and 1 plus 2t. This is the value of OR minus OS. Now use the other position vector. This one we can use here. 25 minus t and 25 minus t. Minus t, 25 minus t. Solve the corresponding numbers. Minus 2 plus t. This goes here, minus 25 and plus t. Same way, the bottom numbers, 1 plus 2t, minus 25, and this minus will make this minus plus t. Now solving, minus 2 and minus 25 will make it minus 27, and t plus t will be 2t. We can write as 2t minus 27. 2t plus t equals to 3t, minus 25 plus 1 is minus 24. So we can write in vector form, SR equals to 2t minus 27, this is the coefficient of I, plus 3t minus 24, this is the coefficient of j. I think this is exactly as required. Let's go back, I will show you. Yes, this is exactly as required. Meters. As required. So part C is done. Now for the last part, D. Last part of this question, find the time when the distance between R and S is minimum. When the distance between R and S will be minimum, first of all, you need to find the distance between R and S by using the magnitude of for this vector. If you find the magnitude of this vector, then what we will do now, we will, to get the minimum distance between them, you have to put the derivative of that distance equals to 0. And from there, we will get the time. Got it? First of all, you need to find the magnitude of this vector. Let's move on. To find the minimum distance, first of all, what we'll do, we will find the magnitude of SR. This will be the distance between S and R. We take the square root of the coefficient of i's. So it will be 2t minus 27 whole square plus 3t minus 24 whole square. This is the distance between R and S. You can take square of both sides to get rid of the square root. And also you can expand the brackets. So it will be 4t square of the first value, 4t square, the product will be 108 minus 108t, and square of 27 will be 729 plus square of the first value, it will be 90 square. Product of these two, 72 multiplied 2 will be minus 144t, and square of 24 is 576. In this step, I just expanded the brackets only. Then d square equals to 4t square and 90 square will be combined together. We get as 13t square. Minus 180 and minus 144 will make it minus 252t. And now 729 and 576 makes it 1305. Now you need to differentiate this distance with respect to time t. Derivative with respect to time t for d square. It will be, power rule, this 2 will multiply over here. It will be 26t and minus 252t. T derivative is 1, so it will be minus 252. Derivative of constant number is 0. For minimum distance between S and R, we should put this derivative equals to 0. As you know that for minimum or maximum, we always put the derivative equals to 0. So this thing will be 0. We get the next equation as 2060 minus 252 will be equals to 0. This 252 goes there and 26 will divide to the other side. So t will be equals to 252 divided by 26. Therefore, this is the time required when the distance between S and R is minimum. So answer for this part will be 9.69 seconds. This is the time when S and R are very close to each other. Or in other words, the distance between S and R is minimum. Hopefully you understand it. If you have any question or any doubt, please write in the comment box. Thank you.